Hello my dears, how are you all? So what we studied in the last class, we discussed about the concept of root stability criteria, right? Root stability criteria, it's very important my dears. So we discussed 2-3 problems regarding the root stability criteria, and we are going to do some more problems because all problems are very important. And by using this root stability criteria, we get not only the concept of the stability, but we can find the frequency of oscillation, right? Everything, no? The range of the constants at which the system is goes to stable, unstable, marginal stable, everything. So you will get a complete information about the system or the nature of the system by solving the root stability or root row, right? Root stable. Okay. So today we are going to do some more important problems regarding the root stability criteria. Write a question, my dears. Write a question. Let Q of S is equal to S cube plus 6x square plus 8s plus k. Find the range of k at which the system is A, stable, B, unstable, and C, marginally stable. Marginally stable. Okay. So we got the characteristic equation. Q of S is nothing but, my dear, characteristic equation. Am I right? Q of S means characteristic equation. So it is directly given the characteristic equation, and we have to find the range of k because k is a constant here. Value is not given, so we have to play with the k now. So for various ranges, for which make the system stable, which makes the system unstable, or which makes the system marginally stable. So first we have to find the value of k, right? We have to get an idea of k now. So for that we have to create the root stability or root table or root stability criteria. So it starts from s cube now. So s cube, s square, s raised to 0. Clear? And for that one alternate 8, and there is nothing, so it will be 0, and 6 and k and 0. Okay, 180 and 6k and 0. Okay, my dears. So how can we find this value? This is nothing but focus on this into this minus this into this divided by this. So it will become what? 6 into 8 minus 1 into k. Always start from here, my dears. Not this into this minus this, but this into this minus this into this. Whole divided by 6. So it will become 48, correct? 48 minus k by 6. So this value become 48 minus k by 6. Okay, and what is this value means, my dear? This into this minus this into this divided by this means 0 and 0. Okay, and what is the below value? Now focus on this value. It will become this into this minus this into this whole divided by this. Whole divided by this means the answer will be simply what, my dear? K. Because this into this minus 0 divided by this means this cancel out now, so remaining only k, 0 and 0. Is it clear? Is it clear, my dears? And I already told you one thing. R of z or row of 0 only occurs when the odd power of s. The odd power of s will be the position for R of z or row of 0. So this will be the R of z. Okay. So let's check the criteria one by one, my dears. First of all, for stability, for stability, this 48 minus k by 6 will not be equal to 0. If 0, then there will be R of z. Definitely there will be R of z, my dear. But for stability, R of Z will happen only at the marginal stable condition. I already discussed it. R of Z will be there only if there is a marginal stability. But now we have to check for stability, not for marginal stability. So for stability, I can write like 48 minus k by 6 should be greater than 0, my dear. Not greater than or equal to 0, but should be greater than 0. Then only this value become positive. Then only this value will make this complete row is not a R of Z, not a R of Z. If it is R of Z means we have to check for the marginal stability. Now we are checking for the stability means this 48 minus k by 6 should be a positive quantity. Should be a positive quantity. Is it clear? So how can I write 48 minus k greater than 0? Correct now? 48 minus k greater than 0. So 48 greater than k or k less than 48. So this is the condition for what, my dear? This is the condition for marginal, stability, k less than 48. Okay? Is it clear? K less than 48. Okay? And one more thing, my dears. There is another k value is there, right? We are checking for stability criteria. So stability, we are dealing with stability means the whole row, column should be what? Positive. And there will not be any sign change, right? If there is any sign change, my dear, the one pole will be lie on the right side of S plane or two pole will be lie on the right side of S plane depending upon the sign changes. So we are checking the stability condition now. For the system to be stable, we are checking. We are looking for the system to be stable, what will be the k value, what that we are going to look. So I can also write like, and this k also be greater than 0, my dear. Correct now? If this k is less than 0 means the system will be unstable because there will be a sign change. If there will be a sign change, my dears, some pole will be lie on the right side of S plane, which will make the system unstable. We are going for the stability condition, not for instability condition. So it will be greater than 0. So combinedly, I can write like 0 less than k less than 48 will be the range. 0 less than k less than 48 will be the range of k at which the system to be stable. So up to 48, if you substitute any value, say I am going to apply 10, I am going to substitute 5, I am going to substitute 37, I am going to substitute 47, then also the system will be stable. If I substitute this 50, k is equal to 50, it will go to the instability. It will go to the instability. Is it clear? Is it clear, my dear? So this is the condition for stability. This is the condition for stability. Now we are going to check it is for marginal stability. So this is for stability condition, right? Next for marginal stability. Next for marginal stability, my dears. For marginal stability. So what we have to do for marginal stability? So for marginal stability, I already explained to you, there will be R of Z. A row of 0 happens, which means this row full is 0. This element also 0. So I can say like 48 minus k by 6 equal to what, my dear? 0. Or 48 equal to k. Simply k equal to 48. So when I substitute with the value of k equal to 48, so we already the system, see the level of the transformation. 0 to 48, the system is unstable. If you substitute 48, the system is marginally stable. If you substitute this, 48, the system is what, my dear? Marginally stable. Next, we can go for the instability. For instability. So what I get for instability, my dear? For instability, this value should be less than 0, right? This value should be negative, then only there will be some sign changes. Then only there will be the chance of instability. Okay, so this value should be what, my dear? Less than 0. So I can say that 48 minus k by 6 less than 0, or 48 minus k less than 0, or 48 less than k, or k greater than 48. So this is the condition for instability, my dear. K greater than 48. This is the condition for instability. K greater than 48. Also, my dear, not only this k greater than 48, this k also what? Chances are there for less than 0. Correct na? We can't suppose this is less than 0 mean at the instant itself it goes to instability. This is pakka. But chances are there for these also should be negative na. Then also the system remain in unstable. If this is less than 0 mean of course pakka the system goes to instability. But there is one more chance, my dear. This also goes to less than 0. Then also the system will be remain in instability. More number of poles jump to the RHS of the S-plane. More number of poles jump to the RHS of the S-plane when these also less than 0. So I can say that and k less than 0. So the range will be what, my dear? K less than 0 to k greater than 48. Correct na? So the value of the range will be what? Less than 0 and greater than 48. Less than 0 and greater than 48. So these two conditions, this you can't combinedly write this, because one is less than 0, another is greater than 48, right? So you can't combinedly write this like before, 0 less than k less than 48. That type, the coordination or that type, the combined writing will not be possible here in k greater than 40 and k less than 0. You can directly give this answer, k greater than 40 and k less than 0. This is a very important question, my dear. This is very important because the roots array is very easy now. Very 2-3 array are there total. Root table is there total. So from that you can check for the stability. I think this type of question this is frequently asked in the examination. A range of k which system unstable. Really sorry, my dear. The range of k for which the system stable, system unstable, and system marginally stable. This type of question we can expect for our examination. Is it clear, my dears? Is everything is clear to you now? Okay, can we go to next problem? Okay, can we do one problem? Write a question, my dear. Q of S is equal to S raised to 4 plus 2s cube plus 3s square plus 2s plus k. Find the frequency of oscillation if system is used as an oscillator. So that's a question. Find the frequency of oscillation if the system is used as an oscillator. See the application of Ruth table now. It is not only used for, I already told you, it is not only used for checking the stability, but why that concept, or with that concept, Ruth's stability table analysis, we can find the frequency of oscillation of a system if the system is act as an oscillator. So control system means what, my dear? If something we can control, the control output is produced in any arrangement, then that is considered to be a control system. So oscillatories are a control system, right? Oscillatory is also a control system. We can adjust the frequency of oscillation. So frequency of oscillation, if we adjust, then that is a control system. So this is the equation of an oscillator. I mean, this characteristic equation referred to the oscillator. It is given actually. So what we have to do? First we have to draw the Routh table or Routh array. So it is nothing but, my dear, s raised to 4, s cube, square, s raised to 0. Okay, so it will become what? 1, 3, correct na? 1, 3, 1, 3, k. And next 2, 2, 2, 2, 0. So what will be this element, my dear? So this element focus on this into this minus this into this. So it will become 6 minus 2 by 2. The answer is 2. Okay, the answer is what, my dear? 2. And next element is this into this minus this into this divided by 2. So it simply gives to k. Another is 0. And what will be this element, my dears? Focus on this into this minus this into 0 by this, which means 4 minus 2k divided by 2, or simply 2 minus k. Am I right? 2 minus k. And what is this element, my dears? What is this element? Focus on this again. This into 0 minus this into 0 by this means plus 0 and 0. What is this element? Simply what? Focus on this into this divided by this, and this into this, correct na? This into this minus this into this divided by this. So it will become simply make k only. So this is the Routh array, my dears. This is the Routh array. 2 minus k, 2k, 0, 2 minus k, k, 0, 0. Okay, so this is the Routh array. So listen, my dear. Find the frequency of oscillation. For oscillation, pakka we know that. For oscillation, pakka we know that there will be imaginary roots. Then only there will be oscillation, of course. I already told you. I already told you that if we plot the S something in, I mean the concept in S and j omega planes, or sigma and j omega plane, if we get some imaginary roots on the axis, then we can say that the system is marginally stable. Of course there will be an oscillation. Or simply suppose the pole is here also, then also some imaginary term is there now, there also some oscillation will be occur, but pakka sure shot there also an oscillation will occur. Suppose I consider this pole and this pole and this pole, means that is uncertain poles. We don't know where that exactly, but for this we give a strong idea. We can give the strong mentioning here because it is on the imaginary axis. That means if arrow said he is here now, arrow said I already told you it is in the odd power of s, always the arrow said happens. So if s raised to 1, if arrow said happen, my dear, how can I say that? This element also goes to 0 because it is already 2 zeros. So I can say that k is equal to 2. I can say that what? K is equal, because 2 minus k is equal to 0, or k is equal to 2. Is it clear, my dear? If this is 0, my dear, this 0, this 0, this 0, what is we normally done for finding the remaining section? Or this 0, this 0, this 0, how can we proceed then? We already discussed. This 0, this 0, this 0, I mean just make the auxiliary equation. So what is that? A of s. A of s is nothing but, my dear, just above one row, which is nothing but 2 s square plus k equal to 0. Am I correct? Or I can say that 2s square plus k is value is 2 equal to 0. Or I can say that, or implies 2s square equal to minus 2, or s square equal to minus 1. Correct now, my dear? Or I can say that minus s square equal to minus 1 na? So I can say that s equal to plus or minus j. S is equal to what, my dear? Plus or minus j. This plus or minus j means plus or minus j into 1 na? If it is plus or minus j means in between hidden it is 1, right? So j into 1. So S is equal to plus or minus j omega. This is in the form of plus or minus j omega, implies omega equal to what? 1 radian per second. Omega equal to what, my dear? 1 radian per second. Is it clear, my dears? See how can we arrange some answers like this? It is very deep concept, I know it's very difficult. If you are looking this for very first time, then definitely you will feel very difficult, my dears, but don't skip this. Focus. Okay, everything will be clear to you if you continuously revise this. Definitely it will be make you more and more clarity. Okay, there is a very big possibility for asking this type of question, my dear, because the question is simple, one line, the answer also just 2-3 lines. There is a chance of asking this type of question is very high in control system. They will not ask you draw the polar plot or draw the Brode plot. These chances are very less. But for asking this type of question, it's very high, very high. Okay. Is it clear, my dears? Can we do another problem? Can we do another question? Write another question, my dears. Q of S equal to S square plus A square plus 2S plus 1 plus KS plus K equal to 0. Not equal to 0, simply okay, equal to that. Frequency of oscillation omega equal to 2. Find A and K. 2 means it's understood not 2 radian per second. Find A and K. How to find both? Find A and K. How to find both? Okay, how can we do this? Again, you have to go for the Ruth array, correct? No? Again, you have to go for Ruth table. So, what is this? Before that, we have to rearrange the equation, my dear. Q of S is equal to, I can say like this, S square into 1 plus A, because I can take common S square, so S square into 1 plus A plus S into 2 plus K plus 1 plus K, right? This will be the standard form, right? 1 plus K, this will be the standard form. So again go for the Ruth array, so S square S correct now? So it will become 1 plus A alternate 1 plus K, correct now? This one and alternate one. Skip this and go to next, so 1 plus K. Next one 2 plus K 0, there is no alternate. And what will be this element, my dear? This element will be, focus on this, so it will become this into this minus this into this divided by this. So this is already 0, so this into this by again this means remaining only will be 1 plus K. Remaining only will be 1 plus K. So 0. So this is the simple what? Ruth array. So it is given that frequency of oscillation will be 2 radian per second. Again, you have to go for the R offset concept. Here there is a chance of making R offset will be now here, because odd powers of S will always the place for R offset. So this is S raised to 1. So odd power of S will be always the favorite place for our R offset. Okay. So R offset means what, my dear? This K also equal to what? Minus 2. Am I right? K is equal to what? Minus 2. K is equal to minus 2. Okay. So now you got the value of K but we have to find the value of a also. Am I right? We have to find the value of what, my dear? A also. So what for that? If this is 0 means, how can we proceed if it is in normal condition? If this is 0 and this is 0 means go to the or make the auxiliary equation. So I can say that a of s will be now equal to what, my dear? 1 plus a into s square plus 1 plus k equal to what, my dear? 0. A of s equal to 0, you have to solve now. A of s equal to 0, you have to solve. You will get the auxiliary equation. I mean, you will get the nature of the pole also. So now we can say like 1 plus a into s square plus 1 minus 2. Correct now? K is equal to minus 2, right? 0. Or which implies what, my dear? 1 plus a into s square minus 1 equal to 0, or 1 plus a into s square equal to 1, or s square equal to 1 divided by 1 plus a. S is equal to s square equal to 1 divided by 1 plus a. If there will be a possibility of oscillation, my dear, I already told you there will be what? Imaginary poles on the what? The axis, y axis, or the imaginary line. There should be some poles. So for that, my dear, there should be some j term in the equation, some j terms in the equation, some minus j terms in the equation. This s square na, this s square equal to something na, this should be what? Negative. For making oscillations, s square equal to 1 by 1 plus a na, this should be negative. This should be negative. Then only I can write s is equal to plus or minus j 1 by root of 1 plus a. Then only I can write na. If s square equal to minus something, then only I can take root and I will obtain j term from that. Then only I can plot something from something like this. If frequency of oscillation happen, my dear, definitely there will be some j term and upper and above and below some j terms will be there. That is the marginal stability condition. So if s square equal to plus j, it is simply here means, if you take simply s is equal to 1 by 1 plus a means s is equal to what? Simply 1 by root of 1 plus a, which is a positive quantity, which means there will not be any oscillation condition will happen. If there is an oscillation condition, my dears, definitely some j term and minus j term will be there. For making this j term, for s value, this term fully should be negative. Then only we can, if it is only minus, then only we get plus or minus, then only we can introduce j there. Then only we can introduce j there, my dears. Otherwise we can't introduce j there. If we can't introduce j means it will not be frequency of oscillation. It will not oscillate. If it is start oscillating means there will be some j omega term. Of course there will be some j omega term. Is it clear? Is it clear? So what we obtain now? So it will be plus or minus 1 divided by j divided by 1 plus j, which means plus j into 1 by root of 1 plus a on top and minus j into 1 by root of 1 plus a on the bottom. Is it clear? Is it clear? Is it clear, my dears? Which means listen, this term this is equivalent to what, my dear? Plus or minus j omega. In previous case we discussed the same thing. This is equivalent to plus or minus j omega, which means omega is equivalent to this much. So I can say that it implies omega will be equal to what, my dear? 1 divided by 1 plus a, or omega square will be equal to 1 divided by 1 plus a, or 4, omega will be given 2 now, so 4 will be equal to 1 divided by 1 plus a, implies 4 plus 4a square equal to 1, 4a square equal to 3 minus 3, a square equal to minus 3 by 4, or a equal to what, my dear? plus or minus j root of 3 by 4 equal to what? Plus or minus j oh sorry, not a square na, it is simply a, my dear, a. 4 plus 4 a na, 4 plus 4 equal to 1, 4 plus 4 equal to 1. Or I can say that 4 equal to minus 3 or simply equal to minus 3 by 4. Minus 3 by 4. If I substitute a equal to minus 3 by 4 here, my dears, what happens? S square will be a positive term. S square will be a positive term, which means the answer will be none of the above. The answer will be none of the above. Very, very important concept, my dear. Very, very important concept. Because we proceeded in the way that we given in the question, but finally we got a less than minus 1. We got a less than, a less than 1. If you substitute a here, if s square equal to negative, if you are, suppose the a square value, suppose you put a value here, the a value makes the s square equal to minus something, then our analysis is correct, or the answer will be something from, or I can say that a will be minus 3 by 4. For k value we already obtained, my dear, k equal to minus 2. For a, it is, we can't find a, actually that is the answer. That is the actual answer. Or none of the above will be the answer. Is it clear, my dear? Is it clear? So the complete answer will be k equal to minus 2 and a not find. I mean not able to find or couldn't find. Not able to find. So that will be the answer finally. Is it clear? Is it clear? If it is confusing, my dear, revise my video. The same video you have to revise from the first. Definitely very many points I have discussed in between. Collect it, note it somewhere else or somewhere. Definitely you will understand. Definitely you will understand. Okay? Because it's a high level problem actually. It's a high level problem. We can't expect this type of problem for the AEJ exams or sub-engineer exam. This may be higher level, assistant professor or gate level exam. Gate level problem is actually this. Okay? For making K it's very easy, but for finding A it is difficult. So the answer will be none of the above. The answer will be what, my dear? None of the above. Is it clear? Is it clear? Okay. Write another question, my dears. Determine the range of 4. Determine for stability. Listen, my dears. For finding anything, the range of tau or anything, we have to, the system stability means definitely give first preference, you go for the root stability criteria. If the question is regarding the stability, my dears, don't go for the body plot, polar plot or any other plots or something like that, but you can easily go for the root stability criteria. If the characteristic equation is given and they are hint or mention a word stability, you can blindly go for the root stability criteria. Listen my dear, so GH is given 1 minus S tau divided by S into S plus 1. We have to determine the range of tau for stability. What dear? Listen, we already have some Q of S value, correct now? Some Q of S. What is this Q of S means? It is the characteristic equation. The characteristic equation is nothing but, my dear, the characteristic equation is nothing but transfer function. You have transfer function that is nothing but G divided by 1 plus GH. This 1 plus GH equal to 0 is called the characteristic equation. This 1 plus GH equal to 0 is called the characteristic equation. Now, GH is here, my dear. So, what will be characteristic equation? 1 plus GH. 1 plus GH. Clear? So, characteristics equation equal to 1 plus GH, my dear, equal to 0. Correct, na? Characteristic equation implies 1 plus GH equal to 0. GH is there. So, which implies 1 plus G into H is 1 minus S tau divided by S into S plus 1. So, it will become, my dear, which is equal to 1 plus GH equal to 0. So, which implies S into S plus 1 plus 1 minus S tau divided by S into S plus 1 equal to 0. Equal to 0. Or simply I can say like S square plus S plus 1 minus S tau equal to 0, or which implies S square plus S into 1 minus tau plus 1 is equal to 0. So now you got the characteristic equation right here. So this is nothing but Q of S. This is nothing but my Q of S. Okay. This is nothing but my Q of S. Okay. Characteristic equation is simply 1 plus GH. Okay. Not equal to 0 is used for finding the poles. Finding the poles. Simply this 1 plus GH is called the characteristic equation. So no need to write here. Yes, you can write definitely. You should write. 1 plus GH equal to 0 is the characteristic equation. So characteristic equation equal to 1 plus GH equal to 0. Okay, pakka. So now you have S square plus S into 1 minus tau plus 1 equal to 0, which is nothing but my Q of S. So now you can go for the root stability criteria. Am I right? Am I right, my dears? Now you can go for the root stability criteria, which is nothing but what? S square, S and S raised to 0. So which is nothing but, my dear, 1 alternate. This is 1. Okay, next one. 1 minus tau alternate 0. What this will be this element? This will be 1 minus tau into 1. 1 minus tau into 1 minus 0 divided by the same 1 minus tau. The answer will be simply 1. It is 0. For stability, for system stability, my dear, for system stability, this 1 minus tau should be greater than 0, right? That means there should not be any R of Z, region of 0 or rho of 0. 1 minus tau greater than 0, or tau or 1 greater than tau, or tau less than 1. Tau less than. So that is the range of tau for the system to be stable. The systems to be stable. This type of question you can expect, my dear. So chances of asking this type of question is very, very high, because it's 2-3 line only, and also it contain a core level of what? Thought process. So the chances of asking this type of question is very high. Is it clear, my dears? Is it clear? Can I rub this? Write another question, my dears. check the stability. Check the stability. Okay, again the simple process you have to start with. What is our root stability array or root array? One, alternate two, alternate three, nothing is there. Next one, alternate two, alternate two, alternate 15. Okay, now what will be this element, my dear? This into this, focus on this, and this into this minus this into this by this. This into this 2 minus 2, 0 by anything will be 0. Second element, this into this minus this into this by this. So it will be 3 minus 15. 3 minus 15 by 1. Minus 12. Correct now? 3 minus 15 is nothing but minus 12. So it will be minus 12. And next element is nothing but 0. So that's the but 0. If suppose, what will be this element, my dear? What will be this? This is of course not R of 0. If R of 0 means we can go for auxiliary equation and you can solve for d by d a of s divided by ds will make you the new row you can make from that. But this is not R of s. This is of course not R of z, but one element is non-zero. If one element is non-zero and the rest of all 0 means, can we go to next step? See, what will be this element? This into this minus this into this divided by this. It will form infinity. It will form infinity. Now this into this means 0. Minus this into this, there will be something. Divided by 0 means something by 0 is infinity. You can't go for infinity like condition. And if you make this infinity, next thing, 0 into 0, 15, again 0, 0 by 0. This element will be 0 by 0. This is indeterminate form. We can't go for that indeterminate term, ideas. There should be a finite term, there should be a determinate term. But the 0 by 0 form for the next element will be indeterminate. So what we do? So for that, my dears, you have to make a small assumption that this is 0 now. This 0 is making all the problems now. So we have to avoid that problem, right? So for that, assume a small value of this, replace this 0 with a small value, my dear, which value is tending to 0 always, at which value will be always tending to 0. That much a small value, 0.000009 or something, which makes this 0 is non-zero. Some value will be there now, then. And continue our analysis with the A. Continue our analysis with the A. Okay, I will say. So what will be this element then? Now your 0 will be replaced with the A. So focus on A only. So this into this minus this into this by this. So it will become 2A. Correct, my dear? 2A minus, or minus will mean plus 12 divided by A. And this element will be, so this is this element now. This element will be what? This into this minus 0 divided by A. So it will be simply 15. Correct now? 15A minus 0 by A means it is simply 15 now. So remaining it is 0. And what will be this element then? This element will be what, my dear? Focus on this. This into this minus this into this divided by this. So we will do that. So it will be 2A plus 12 divided by A into 12 minus 15A whole divided by 2A plus 12 by A. Or simplify this, my dear, you will get 24A plus 144 by A minus 15A whole divided by 2A plus 12 divided by A. So again simplify this, you will get 24a plus 144 minus 15a square whole divided by a whole divided by 2a plus 12 divided by a. This a and a get cancelled. The remaining answer will be 24a plus 144 minus 15a square whole divided by 2a plus 12. So this will be the final answer. This will be the final what answer. So can I write this? 24a plus 144 minus 15a square whole divided by 2a plus 12. And the next element will be what? 0, right? 0. And what will be this element here again? What will be this element? This into 0 na? This into 0 minus this into 0 divided by this. So it will be 0. 0. No. Listen. This element will be what, my dear? This into this na minus this into this divided by this. Correct? I mean mistakenly taken what? 0. This into this. No, this into this na. This into this minus this into this divided by this. So it will become divided by this means into 0 and divided by this means the same thing will remain there. So only 15 will be there, right? 15 and 0. 15 and 0. Correct? Is it clear, my dears? Is it clear? And second element will be now here 0. Okay, now the problem solved, I think. Now the problem solved, correct now? So what do you get finally? It is minus into minus 12 na, my dear, into minus 12 na. This is into minus 12 na. So the answer will be minus and again it will be minus. Correct na? It will be minus. That's it. So the final answer will be again minus and minus. So it will be minus and minus. Okay, so minus 24a minus 144 minus 15a square divided by 2a plus 12. Correct. So that is the root array, my dear. That is the root array. And next step is that you have to substitute for a is equal to 0 now. Now everything will be in 0 term now. Now you have to substitute for a is equal to 0 because we assumed a tends to 0 now. We assumed a tends to 0 initially now because we have to find the remaining rows, my dear. If we simply take this 0 means we will stuck everywhere. Some indeterminate form will happen, some 0 by 0, some infinity will come again. Okay, so for avoiding that we considered or we assumed some value of a which is tends to 0 and now we got the root array. Now you can again draw this root table once more, my dear, and just write the first column. So first column is 1, so 1, second is also 1, third is a we imagined tends to 0 and substitute a equal to 0 here, my dears. So what do you get? Suppose you got a is equal to 0 here, what you get? 2a, 2 into 0 plus 12 divided by 0, infinity. Okay, infinity, good. Next is you substitute a is equal to 0 here, 24 into 0, 144 divided by 12, it is what? Correct na? 144 by 12 is equal to what, my dear? 12. Again 15. Again 15. 15. Oh, it's all minus na, minus, this is also minus na, so minus 12, correct, minus 12 and 50. Now you can check the stability. So RHS poles equal to, how many RHS poles are there? Sign changes. Positive, infinity means plus infinity na, so positive to negative, negative to again positive. So two sign changes are there. Two poles will be lie on the RHS of S plane. Two poles will lie on the RHS of S plane. And what will be LHS pole? LHS poles will be, it is a fifth order equation, my dear. So the remaining all poles will be on LHS. Because there is no R of Z happened. There is no R of Z happened. If some R of Z happen, there will be one pole on the imaginary axis itself. Some J omega axis, in that axis some imaginary poles will be there. If R of Z happens, but nowhere R of Z happened. So we can blindly go for, if two poles RHS means remaining three poles will be LHS. Okay. My dear, the level is very high for this type of problem. You should think, my dears. You have to think a lot. Otherwise it will be difficult. I already told you control system is a very difficult subject in electrical engineering. Okay. So your level should be, you have to raise your level to that much. Then only this problem will be easily understandable. Otherwise it will be very, very difficult. Very, very difficult. Okay. Okay, my dear. So that's all for today's session. We wind up with what? We finished that root stability criteria. From tomorrow we go to Bode plot. That's very important. Root locus actually it is not in your syllabus, my dear. So I am going now strictly according to your syllabus. And after the completion of syllabus, my dears, I will take root locus or M circle, N circle, etc. Some special topics are there na? That I will take later. But for now, the syllabus wise, after the root stability criteria, root locus is not there. Thank God, because it's a plot, very, very big plots are there. For competitive examination, there is no important for that type of big problems. So next we will go to Bode plot. Okay, that's very important. That also very big problems are there, but in syllabus now, so we have to follow definitely. So that's all for today, my dear. So please continue watch my channel. If someone else or someone in your fraternity, I mean in your area or in your contact, those who are preparing, please send to them. They will be also get benefited. Okay. So thank you so much.